Hey students, this is a question for radioactivity O-level physics, and this is one of those questions which is somewhat tricky, and let's solve this thing. The question starts uh, with a source contains a radioactive material. Without a radioactive source present, a detector records a background count rate of 20 counts. This source is placed in a fixed position near the detector. Initially, a count rate of 520 per minute is recorded. What count rate is recorded after a time of 2 half-lives of the radioactive source? Now, there are some terms that you need to understand. Background count, 2 half-lives. First of all, what is a background count? Background count is the reading taken by the detector from the atmosphere, which comes in the types of sources like cosmic rays. These cosmic rays are released in an event known as supernova, when a star dies and it releases cosmic rays which are detected by our GM counter on any other detector we are using. Second is from the crust of the earth, as the crust of the earth contains radioactive minerals like radium, which also emit radioactive waves radio waves not radio waves radioactive. They act as a radioactive source, and thus it is detected by our detector like radium. Now, yes, it has an effect on the reading. If the final count rate is 520 per minute, it means the count rate of the source will be calculated like this. Reading is equal to the count to the background plus the source. Now we have to understand, this is the final reading, this is the final reading, and this is the background count, and this is the count released by the source. Like here we have a radioactive material. Now the reading is 520 and the background count is 20 plus source, so the count rate of the source will be source is equals to 500 counts per minute. Now, 2 half-lives. We know what the half-life is. Half-life is the time is the time period when count rate halves. It means that the count rate is divided by 2, or it halves, and this time period is fixed. Now, for the first half-life, 500 upon 2 is equals to 250. Now, 250 upon 2 is equals to 125. Now, after 2 half-lives, the count rate will be 125 counts. Now, if you are a student, you will immediately select A and go on with the answer, but it is wrong. This is wrong because it does not say the count rate of the source. It says what count rate is recorded. Now we have to break it down. It is asking us what is the count rate recorded after a time of 2 half-lives. We know the count rate will be halved 2 times. 500 is divided by 250, and 250 is divided to 125 counts per minute. Now, what will be added in the reading? We know what is reading. Reading is background plus source. It means reading reading is equals to 1 125 plus 20. Why are we adding this 20? Because of the background count. So the answer will be 145. So answer is D. Now let me break it down first. हमें पता है काउंट रेट तो होगा, उसने ये नहीं पूछा कि काउंट रेट क्या है ऑफ द सोर्स, उसने कहा व्हाट इज द काउंट रेट रिकॉर्डेड, और उसने बोला काउंट रेट रिकॉर्डेड, नॉर्मल काउंट रेट पूछ रहा है जो जीएम काउंटर है, कोई चीज रिकॉर्ड कर रहा होगा, उसने हमें ये नहीं बोला कि क्या काउंट रेट है ऑफ द रेडियो एक्टिव सोर्स। अब हमें रीडिंग निकालने का हमने फॉर्मूला बता दिया भाई, बैकग्राउंड काउंट प्लस सोर्स का काउंट रेट। बैकग्राउंड काउंट तो 20 ही रहेगा, बट सोर्स का हमने निकाल लिया आफ्टर 2 हाफ लाइफ, 125 हो जाएगा। तो उसका मतलब जो काउंट रेट रिकॉर्ड कर रहा होगा आपका जीएम काउंटर, वो क्या होगा 125, which is the count rate of the radioactive source, plus the background count, which is 20. तो 125 plus 20 is equals to 145. Now इसमें एग्जामिनर का सीन ही ये होता है कि एग्जामिनर आपको ट्रिक करना चाहता है कि आप गलत आंसर सेलेक्ट कर लें, क्योंकि उसने 125 दिया हुआ है। अब कोई बंदा जल्दबाजी के अंदर आकर 125 सेलेक्ट कर लेगा तो आंसर क्या हो जाएगा, उसको गलत हो जाएगा, क्योंकि हमने उसके अंदर बैकग्राउंड काउंट को ऐड ही नहीं करा। और अगर कोई बंदा 520 को लेकर सॉल्व करने लग जाएगा डायरेक्टली और उसमें प्लस 20 कर देगा, वो भी गलत हो जाएगा। तो इसको आपको मद्देनजर रखना पड़ता है कि कभी भी always always make sure that the background count is always taken account in your answer, because it is always being checked by the examiner, because it is important thing to understand in the physical world we live in. Theoretically background count हम नहीं समझ सकते, but फिजिकली जब भी हमको एक्सपेरिमेंट कर रहे होते हैं उसमें एरर का चांस होता है। तो एक तरह से बैकग्राउंड काउंट को हमें जो सबट्रैक्ट, और जो मैंने सर सोर्स का जो निकालने के लिए मैंने सबसे पहले बैकग्राउंड काउंट क्यों बगैर सोर्स रखते हुए मैंने एक बैकग्राउंड काउंट क्यों लिया, बिकॉज बैकग्राउंड काउंट इनडायरेक्टली एक्ट कर रहा है एज अ जीरो एरर। मतलब इन कंपैरिजन, जैसे अगर आप वर्निकल if you're using a vernier caliper or a micrometer screw gauge, we have to first check if it does not have a zero error, because if there's a zero error there will be a constant deviation in our result, because in every reading we will record for a different types of samples there will be an increase or decrease in the original value which we are measuring. So we have to first calculate the zero error, whether it will be positive or negative, and we have to subtract or add depending upon the type of the error to get the original value. So in this case, background count is indirectly is measured to eliminate the systematic error in this experiment, so that we can get the original value of the count rate of the radioactive source. Thank you.